Good morning students, this is your teacher Neela Behlawat and today we'll start with the graphical equation of motion second and third. We'll discuss the equations second and third. I hope you remember we've discussed about the first equation. So who will tell me the first equation of motion? Tell me what is it, the first equation of motion, everyone? Yes, V is equal to U plus AT. What is the first equation? V is equal to U plus AT, where V is the final velocity, U is the initial velocity, A, the small a, denotes for acceleration and T denotes for time. So we'll derive today the second and third equation as well. Now let's start with the first equation. The first equation is called as velocity-time relation. Okay, dear students, it is called as velocity-time relation, or we can say it is S is equal to ut plus half at square. Okay, everyone? Right? So S is equal to ut plus half at square. So we assume that the object was at position A. Now it has shifted to position B when we have applied some force on this object. Okay, the object was at position A, now it has shifted to position B, right? And this distance is S and it has taken the time A. Its velocity was U. Initially the velocity was U and now the final velocity is V. So obviously its velocity has changed. Its velocity was U, now it is V. So velocity has changed when it has changed its position. Okay. Now we'll represent this in a graphical way. Now this is our graph. Where was the object? The object was at position A. Now it is at position B. Initially the velocity was U and it is final velocity is V and has taken time T. Now on x-axis we have taken the time. Okay, the graph is between velocity and time. So on x-axis, this is your x-axis. So on x-axis we have time and this is your y-axis. On y-axis we have taken the velocity and we have plotted the graph. So a graph is a straight line. Okay, dear student, the graph is a straight line, isn't it? Now let's use a second, we'll use a second color. Okay, now just see this. I'm just underlining it for you. Look at this portion of the graph, which is I'm underlining with blue. Now this is a trapezium. Okay, this is a trapezium. So your OABC is a trapezium. This is OABC. It is a trapezium. Okay, OABC is a trapezium. Now we want to calculate the area of this trapezium. So area of trapezium OABC will be equal to the area of triangle, isn't it? This is a triangle. So area of triangle plus area of rectangle, isn't it? AODC. AODC is a rectangle and ABD is your triangle. So area of trapezium is equal to area of triangle ABD plus area of rectangle OADC. Right, everyone? Is it clear? Right. चलिए आगे चलते हैं फिर. Now we can say that the area of trapezium is equal to OA into OC. That is your area of rectangle. So area of rectangle is L into B, isn't it? आपका area of rectangle क्या होता है? L into B. ठीक है, L into B. So this is your L and this is your B. This is your rectangle, isn't it, students? So L into B. Okay, and that is L into B is OA into OC. Okay, OA into OC plus area of triangle. Area of triangle क्या होता है? Half into base into height. I hope you remember. Area of triangle is half base into height. So this is your height and this is your base. So half into AD. Okay, half into AD. This is your AD. So half into AD plus BD. Plus BD. BD is your perpendicular. Okay. Base is AD and height is BD. Okay. So area of rectangle plus area of triangle. Now your OA is equal to U. OA is equal to U. Your OA is equal to U. OC is equal to AD, that is your T. And your BD is equal to V minus U, that is equal to T. Okay, let's put this values. So what is OA? OA is U and into T. OC is T. So U into T plus half. AD is what? AD is T and your BD is AT. So it becomes S is equal to UT plus half AT square. Okay, S is equal to UT plus half AT square. And this is your second equation. We have derived the second equation. Okay. Now there are two things important in this equation. Area of rectangle and plus area of triangle. These two things, they are very, very important. Okay everyone? Okay. So shall we start with the third equation? Let's come to the third equation. Third equation of motion is called velocity time relation. It is called velocity time relation. Okay? Clear? It is called velocity time relation. So this equation is 2as, which is equal to v square minus u square. This is your third equation. We have to derive this equation. Again, suppose the object was at A position A, right? Then we applied a force, the object, it has moved to position B. ठीक है, हमारी एक ऑब्जेक्ट है जो A पर प्रेजेंट थी, हमने इस ऑब्जेक्ट पे फोर्स लगाई है. Now object has moved to distance B. So this distance is S, it has taken time T and A is the acceleration. Okay dear students? So this is your initial concept. We have applied a force on the object and object has reached position B. Now its velocity was U. जब ऑब्जेक्ट आपकी पोजीशन A पर थी तो उसकी velocity U थी. Now its velocity is V. So again we see that the velocity has changed, isn't it? The velocity has changed. So it will have some acceleration and your acceleration will be equal to V minus U upon T, right? I hope this you've understood. Okay, let's come to the next. Now again here we will calculate S. Okay, area S. This complete area we will take out. So we have to calculate the area of trapezium. Again we will see this. This is again your trapezium. Okay. And the name of the trapezium is OABC, right? The area of trapezium is OABC, right? And area of trapezium is again equal to area of triangle, isn't it? Area of triangle plus area of rectangle, right? This is your triangle AD and this is your rectangle AODC. So your S becomes equal to OA plus OC into OC upon में 2, right? OA, this is your OA in plus BC, ठीक है, plus BC, this one, okay, OA into OA plus BC into OC, okay, this one, OC is this one. Now OA is U, BC is V and your OC is equal to T. Now let's put the values in the equation. Let's put these values. So your S is equal to U plus V into T by 2. Okay. So from velocity time relation, we know that T is equal to V minus U upon A. देखिए A is equal to V minus U होता है. अब ये भी just we have calculated. A is equal to V minus U upon T. So T will always be equal to V minus U upon A. So we'll use this equation also from the first equation. That is T is equal to V minus U upon A. Now put both the values here. So S is equal to U plus V multiplied with V minus U upon 2A. So if you have A minus B and A plus B, so what it becomes? It becomes A square minus B square, isn't it? So here you have V plus U, V minus U. So V plus V minus U or multiplied with V plus U. So what it be equal to? It will be equal to V square minus U square. V square minus U square. It will be equal to V square minus U square. So yes, S will be equal to, okay, this will multiply here. So 2AS is equal to v square minus u square. 2as is equal to v square minus u square. Okay everyone? It becomes equal to 2as is equal to v square minus u square. Okay. So this is your equation number 3. So dear students, if you are asked to derive graphically, you have to derive it from the graph. Or if you are simply asked derive the equation, then you can use a simple method of derivation. ठीक है, अब आपके पास दो methods हैं equation को derive करने के लिए. एक जो हमने पहले किया था simple method, और दूसरा जो हम आज कर रहे हैं that is your graphical method. So you can choose any method, right? You can use any method. But if in exams, if they ask you to derive graphically, you will derive it graphically. Okay. Now let's come to your homework. First of all, make notes of this topic. Okay. And then you practice the question answers from the exercise. Because with this topic, we will finish the complete chapter. So you are required to complete all the question answers of your exercise as well. Okay, dear students. So you try to complete. And if there is any doubt, you can ask me, right? Okay, everyone. So, bye.